Hi, today we are going to talk about the lecture 1 and 2 for today we are going to talk about lecture 1 and 2 for database development. And for there are three, we should put up your hand, write to student, and ask question after lecture. Only attendance are in lab section. This is the e-textbook. We have the paper base. The database is that it reflects the updated aspect of the real world, and so it consists of a logical collection of data, and it has been built for a specific purpose. So how does the logical connection here? The logical connection, I'm not sure. So maybe I can take a picture and ask them on the how to say it on the blackboard, and I can tell the tutor about the discussion board, and maybe general questions, start a trend. So the subject is what are logical connections here. And we can add album. Logical connection. Collection. Logical collection. And then I can post it now. Oh, failed. Why? What are logical stand up? Oh, why? Why? It should be fine. Why? Start trend. Oh, I see the reason, because I did not connect to the internet. So I should connect to the internet here because I'm new to this room. I should connect that to the internet, and hopefully it is fine, and I can start the trend now. Let's see whether it is workable or not. Come on. This is a bit embarrassing that due to the poor internet connection, I cannot make the post here. That is a bit annoying, and maybe I should just, you know, make them and comes to here. So let's continue talk about that. And so database are everywhere and are valuable. So the main computer internet is based on the user web service and the database. So this is front end, this is the back end. We can have the online store, social media site, the airline train, and so forth. And actually, it is millions of users per day and more than 400 more than 42 TB of data and more than 60 million active users, millions of products. And we have the databases drive the web, which means we have the 1.13 billion of more than 1.13 billion of users daily, and we have the user information, links, posts, and pictures more than 10 times of the servers than the Amazon, and loading the pages of user required accessing. So what are the ads here? I'm not very sure about this ads. So I'm not very sure about this ads. So what is this ads? And can I make a correction here? Or send to? Well, I do not have this kind of I am thinking that whether it is possible, maybe. What are these ads here? And oh, I have the internet connection. Oh, great! So let's go back to Blackboard and start now. Starting the trend. Will be fun. No connections. Okay, cool. And I have another question. Is that start a trend? What are these ads here? Okay, so maybe. Oh, maybe I will change that to change it. And what are these ads? What are these ads here? And we can copy it and send it to Blackboard. So what is S? What is S? and we can see we can add from the elbow down. We can start now. I think, and I have the questions, and we can have the okay. Let's continue. So requires extremely efficient system for requiring data and for storing and manipulate in a safe way. So the database drives the business. For example, for the banking system, we have the credit card and the debit card transactions. For example, in the stores, in the supermarket, and for the stock markets, and for the big companies and organizations, we have the employers, customers, products, sales, schedules, logistics, client, and purpose. It's some are worthwhile directly management, data analysis, and decision making. So all these business scenarios need to use the database for. All this that scenario needs to use database for querying the data directly, and the database in the science and public service. For the science, we have the data management, data analyze, maybe in the astronomy and in the human genome, the biochemistry is exploring the properties of the proteins, biology and life science, genealogy, medical and national health services, patient records, disease and the relationship, the treatment, many others. So early data management is that maybe we have the class of student, we have the string, the name as a string, the number as an int, the program as a string, and we have a vector of vector student. We have vector students consist of the information of the student. We have the Anna, and we have the maybe the ID number. We have the program. So the early database management system is based on this idea, and it has the disadvantages which are hard to program, not very robust, especially when dealing with updates with data by many users in parallel, and it's hard to add files to new queries. How to add files to new efficient queries, or how to add files. We need to change the class, and the new queries is that the new queries or start new queries or efficient queries. I mean, this thing is that you cannot. It's very hard. I mean, you need to change the class. Maybe add a new maybe string, maybe gender. So this is we need to change the class, and we cannot. However, in the relational data model, we can maybe create. Alter, yeah, we can use alter. Yeah, and to add some new queries and so forth. So the relational databases come to rescue because it is really sophisticated models and can manage large amount of data over a long period of time. It's very efficient, flexible, and robust. Then it comes to the relational model, which is a reminder that the data organized in relations or tables. For example, this is one relation and this is another relation. And data is required modified at a high level. No need to know how the data is stored and where. It was first introduced in 1970s and dominated by the 1990s. So the relational data model is one of the biggest success in computer science, and we have seen the relational database management system components. We can see that they are query processing, the transactional management, and buffer and storage manager, buffer the storage, So the key thing is that we have the transitional data management. We have for this one we have the autonomy and a durability and the concurrency control. We have the consistency and isolation. Okay, so the query processing will be further after the lecture 12 to 16. The query compiler, the execution engine, the indexed file. Yes, that's pretty much it. The basically meaning of the tool is the query processing and data transaction management. And then we're going to talk about maybe the buffer and the storage for the storage part. And beyond the relational database management system, we are going to talk about the distributed database management system, the MapReduce, and from the lecture 20 to lecture 26, beyond the relational data, we have the object-relational database, and we have the semi-structured database, and we have the NoSQL database. So the lecture 27 to 20 to 30, we have the data warehouse and data analyze, which is kind of the data warehouses and data analyze and data mining, kind of the how to utilize the data stored in the database. So what do you know at the end of the semester? You need to know the transactional management, identification, and application of the principles, underlining the transaction management within the database management system, and advanced SQL from the COMP 107 extended with indexed transaction query optimization, the implementation in problem solving, applications in the application in the problem solving, the object relational models, identification of the principles. For the web technologies, we will illustrate the issues related to web technology, such as the semi-structured data representation, and why does the web technology related to semi-structured data representation and formalism?
Excuse me,
Oh,
did it book this
no. Yeah.
Oh, okay, thank you.
Okay, I will let you now.